All right, chapter 12, problem 7 is blood passes through the capillary bed in an organ. The capillaries join to perform venules. If the blood speed increases by a factor of 4 and the total cross-sectional area of the venules is 10 square centimeters, what is the total cross-sectional area of the capillaries feeding those venules? That's part A. What is the total cross-sectional area of the capillaries? All right, and B, how many capillaries were involved? Their average diameter is 10 microns. All right, so what we have is we have V in the capillaries. I'm going to back up. 4 times V in the capillaries, right, is the velocity in the venules. Okay, because it says right here, blood speed increases by a factor of 4, so the velocity in the venules is 4 times the velocity in the capillaries. All right, the other thing we know is we're not bleeding internally here, so the flow rate is the same for both of these, right? And the flow rate is the area times the velocity equals area of the venules times the velocity venules, right? The flow rate is the same for both of these. And we can write the velocity of the venules, we can say the area of the venules is times 4 times velocity of the capillaries, right? All right, so the velocity of the capillaries drops out. We're looking for the area of the capillaries, cross-sectional area of the capillaries, so that is going to be 4 times the area of the venules. Everything's dropped out, so 4 times 10 centimeters squared, right, or 40 centimeters squared is the area of the capillaries feeding the venules. Now in part B, how many capillaries are involved? Their average diameter is 10 microns. Well, if their average diameter is 10 microns, that means the area per capillary, right, is pi times 5 times 10 to the minus 6, the other minus 6, you know, the one that looks like a 6, times meters squared. That's the area of a particular area per capillary. So the number of capillaries is just going to be the total area of the capillaries divided by the area per capillary. All right. So 40 square centimeters. All right, 40 square centimeters. I'm going to change this for ease. I'm going to change this to 10 to the minus 4 centimeters. Right? 5 times 10 to the minus 4 centimeters, because centimeters, a meter is 100 centimeters, so we get 5 times 10 to the minus 4 centimeters, so that we don't have to worry about units here. And so 40 centimeters squared divided by pi times 5 times 10 to the minus 4th centimeters squared. 40 divided by pi divided by 5e minus 4 squared. Okay, that is 1, 2, 3, 4, 5, 6, 51 million. 51 million. Capillaries. All right, that's it for problem 7.